Hello everyone. We are live officially for our second time together. Our first time was on Sunday at 5 o'clock. If you didn't get a chance to see that session, go ahead and look at it. And we're moving forward, all right? So I'm so excited to be here, and we're gonna get right into it. So here we go. You can tell me where you're tuning in from. If you're in the Bahamas, if you're in the U.S., you can even tell me what school you're going to, whatever. You don't have to share your full name and everything. But welcome. My name is Miss Nelson. It occurred to me that I didn't share a lot about myself, but I'm going to give you a little nugget every day, every time we meet. And then you can kind of put it all together and figure it out, right? So I am from the Bahamas, and I spent 18 years of my life there, but I've been living in the U.S. ever since. And I believe that my experience there and the way doing my exams and the BJC, I was able to get a scholarship that helped me through school. I thought it was so helpful, especially those years when it was a little bit hard, And so I'm passionate about making sure that you have the tools that you need. And even those of you that are about to graduate or prepare for the next steps, I'm excited to be a part of your journey. Let's clarify some things, okay? So legal disclaimer, this is for educational purposes only. So I'm going to share with you and teach you some concepts, but it's all going to be up to you what you do with the information. I cannot force you to get an A. I cannot force you to get a B or to pass your class. You're going to have to put that work in on your own, but I can give you what's scientifically proven. I can give you some clarity on some of the concepts you've learned. I can reteach some of the things you've been taught in mathematics and hopefully provide some clarity for you, all right? And then the ball is in your court. You do with it whatever it is you want to do, okay? So every day, or every time we meet together, which is going to be Sundays and Tuesdays at 5 o'clock, I'm going to do a little bit of an exercise with you. Last time we did like a mindset exercise, and one of the things that came from that was criticism and negativity is the enemy of success, all right? So, or the enemy of growth. So we want to focus on things, okay, how can I thrive in this situation? How can I do better? So today we have another exercise, and I want you to look at these two people on your screen, and you probably know who they are already. So let's take a look. All right, so we have two people. So you probably know who they are. One is Superman and the other one is Wonder Woman. Now, some of you might not really care a lot about these type of characters, but what I want you to pay attention to right now is their stance. Like, how are they standing? Okay. Now, do you think the stance that they have is one of weakness that shows that they're about to lose a battle? Even if they might, they don't look as if they believe they will, right? They look pretty confident, pretty strong. And this particular pose is called the power pose. It's a pose or stance that communicates power, authority, as if you're going to conquer something, as if you're going to do something great. All right. Now, I want you to consider this thought for a moment. Can you imagine now? Before I do that, now there is this, I guess, assumption that Superman and Wonder Woman like each other, right? They're interested in one another. But I want you to consider, can you imagine if the first time Superman saw Wonder Woman, she came into a room looking like this? Okay. What do you think he would be like? Oh my gosh, she is so attractive. The answer probably would be no. In fact, if she was looking like this one over here, he would wonder if something was wrong. Or maybe what if the first time Wonder Woman met Superman, he walked up in the room looking like that? Maybe she might not give him a second look, at least not with the intent to say, oh yeah, I want to go on a date with you. She would probably be like, can I give you your hand to get to your seat, sir? Her approach would be very different. Now, some of you are not really interested in these type of characters, but maybe think about your most prominent or your idol or whatever, someone that you look up to, someone that one day you say, I want to be like this person. Imagine if someone like Steph Curry came onto the basketball field and he looked like that. Okay. You would probably think, man, he's about to lose this game. Or can someone get him a wheelchair? Now, this is not knocking people who have these back problems. I'm sorry about that. But what I want you to understand is when we are about to go into a situation, whether it is that we believe we're going to conquer it whether it is that we believe we're going to fail or not, or we're not sure what's going to happen, I want us to consider that, okay, maybe there's a way that I can set myself up just physically so that I can at least look confident. And looking confident oftentimes can affect how you feel. So what I'm saying is this. Some of you are watching me on a computer or on your phones, and you're sitting like slouching over, or you're like kind of leaning over. I want you to kind of put your shoulders back a little bit, heads up, prop your phone up in a position where your neck is not hurting or anything like that. And that's going to just help you to focus during our time, and also to help you to be a little more comfortable so that you don't get any back pains in the process. Okay, so let's keep going. Here's an idea of how you can sit if you're in a chair or any sort, or sitting. And I keep touching my ears because my headphones are kind of falling out a little bit. So, don't be distracted by that. But we want to just kind of sit up a little bit. And like I said, it's just for helping you to stay focused, and so you don't have back pains or neck pains later. But let's get into what we're going to be doing together now. All right. So the last time we came together, we did an opening exercise, and then of course I'm going to reteach 1 or 2, maybe 3 if we have time, concepts in math that you probably have been taught before, but maybe you didn't understand it the first time. Maybe you weren't sure about certain things, or you had questions about it that you did not get answered. So this is an opportunity for you, and I'm really excited about it. And then at the end, we're going to give an exam prep tip, okay? And it's not just for any exam. It's a study tip. It's something you can literally do right now that can help you to prepare or improve whatever grades you have, or just help you to develop a good study habit, And then lastly, I'm going to give you access to some resources. So this is just also to let you know, the last call we had, there is a link in the description for a worksheet that you can go ahead and practice some of the questions we did in our last session. All right. So let's get started. All right. So here we go. All right. So the last time we met, this was the homework question that we had. I know some of you do not like homework, but you can call it practice work or muscle work if you want. But let's go ahead and tackle it. If this is a question that you're not really sure how to solve, then this just means that you just need to look at the first session. Okay. And I included some timestamps so you can try to kind of just go straight to the question and that you're doing. So how do we solve this? Well, the first thing I notice is there are parentheses. I see a subtraction sign. I see an addition sign. So what do? Well, we can think about order of operations. Yeah. And one of the ways we do order of operations, or one of the acronyms that we use, is PEMDAS. And you can do that. But particularly here, when we did our session on Sunday, we said, okay, if we see parentheses and we see some type of group in parentheses and something's happening between them, we can introduce distributive property. But with PEMDAS, it would also work as well. Okay. So let's go ahead and tackle the parentheses first using distributive property. So distributive property pretty much just says if I have some item outside of a parentheses that's being multiplied by a group, the result is going to be the same as if I took that number, which is the 2, and I multiplied it by each item individually and added their result. So let's go ahead and write that out so it's a little bit more straightforward. So it will be 2 times the first item, which is X, plus 2 times the second item, which is negative 5Y. All right. And you want to make sure you remember that negative sign, because negatives matter. Signs matter in math, and they always matter. All right. So you have to always take care of the signs one way or the other. And then remember at the back, we have this plus 6 that we didn't, 6Y. So we need to make sure we include whatever we have not touched. It doesn't just disappear into the background as if it never existed. You have to keep in mind everything that's in the original question or the original expression. So now let's go ahead and do the multiplication. In the first group, we have 2 times X. So what this is telling us is as if we have 2 groups of X. So how much do we have in total? If I have 2 groups with X in both groups, we have a total of 2 X's. So we have 2X, 2 times X is 2X. Awesome. And now let's take a look at the second set, which is 2 times negative 5Y. Well, it's in this situation, imagine you have, well, let's look at the signs. If I have a negative and I'm multiplying it by a positive or vice versa, our result is going to be negative. So that means the sign between 2x and the next term is going to be a negative because our answer will be negative. And then let's consider 2 times 5y. This is the same as saying I have 2 groups, and in each group I have 5y. Well, how much do I have altogether? Well, if I have in one group 5y and in another group 5y, I have a total of 10y. All right? You can replay that if that's not too clear for you. But let's take a look at the plus 6y, because we have to also remember that it's there too. All right? Now we're almost done. We have not completed our equation, or well, in this case, our expression. And the reason why we're not done yet is because we have to see if we have like terms. One of the things we said before is like terms. One of the indicators that there are like terms, or we can compare terms, is if, and this is considering addition and subtraction, is if they have the same variable. So let's take a look at the variables that are exactly the same. We have a y in this position and a y in this position. So, well, are they alike? Well, notice that the exponent is, well, do they have a written exponent there? No. So the assumption is both of them have an exponent of 1. So that means that, yeah, these are like terms. Why is the exponent important? Well, in one of our earlier examples on the first session, we said that if I have an exponent of 2 on one of the variables and the other variable does not have the same exponent, then they would not be the same. All right. So let's go ahead and combine them. So the 2x can remain. We didn't touch that. But now let's do the math. Here it says negative 10y. Remember, the signs matter. So negative 10y plus 6y. Now, in terms of negative signs and so forth, I want you to look at the number line. The number line is very helpful when it comes to adding and subtracting negative and positive numbers. But for now, we're going to just do the math here. Negative 10 plus 6, or negative 10y plus 6y, is the same as negative 4y. Now, a quick why. Why is that the case? Well, if I started at negative 10, here's my number line. Remember, on a number line, we add to the right and we subtract to the left side. All right. Now, if I'm using a number line, in order to use the number line, the number we're starting at is going to be negative 10. So this is negative 10. And it says that we are adding 6. So that means I need to be going to the right 6 spaces. And so if I jump 6 places to the right, 1, 2, 3, 4, 5, 6, you can go ahead and fill in all of the numbers in between if you want to, but you'll land at a negative 4. All right. Now, let's keep going. This was one of the problems we did, like I said, a homework or a brain muscle exercise. And so that's what your answer would look like. Okay, so you can go ahead and compare that to what you did on Sunday. So what's next? What are we going to do? So what we did not talk about on Sunday was what happens when I'm simplifying using division. We saw simplification when we were doing addition, subtraction, and multiplication, and that's where the distributive property came in. But we did not tackle how do I simplify when division comes into play. All right. We also didn't talk about evaluating expressions, which I'm hoping to get to this time. And then we're going to introduce some word problems, because we talked about how word problems tend to do us like really bad, or we really have a lot of struggles with word problems. So I'm going to give you some little hints and tips on how to convert from a word problem to an expression. And later on in another session, we'll talk about equations. We'll get in depth on equations. Okay. And then we'll have some practice problems for you. Okay. All right. So let's keep going. Simplifying expressions. So what we didn't talk about on Sunday was our order of operations. And the reason why I don't think we're going to go into depth with order of operations, I'm going to simply just upload a video on my channel that talks about order of operation, which is actually already there. So you can go ahead and check that out to get a more in-depth understanding of order of operations. So I'm going to skip that for our time together, and we're going to go straight into expressions and evaluating them. So just a little bit of a review. We went in and we talked about the different parts of an expression, like the variables, the constants, the coefficients, and the terms. You can take a screenshot of this if you need to. And that will help you to understand what I mean and when I'm referring to when I use these words like variable, right? If you heard me use the word variable before and you're like, what is that? A variable is just the letters that we're talking about in our expressions. The constant is the number without a letter, which is going to be the 5. The coefficient is the number in front of my variables. I have 2 coefficients in this example, but I only show the 2. So that's one thing I didn't mention before. And then we have different terms. Okay. So you can go back and check that out. And these were the questions that we tackled the last time we met. Now, if you look at these questions and you're like, there's something here I don't know how to do. Well, go back and watch that video and you'll be good to go. All right, so let's get into it. So simplifying with division. Now this is a whole other topic, but I'm going to try to do these questions without too much extra stuff in there so that we can get through this. And the reason why I'm not going to do too much on this is because when you're doing the exam, for the most part, these particular questions, they don't, it's not a lot of them on the exam. Let me say it like that. So how do we do this? Well, I have 18b squared divided by 9b. Now, division is the same when you're doing with the numbers, right? So 18 divided by 9, you get the same answer as if you were doing just the regular numbers. But then one of the challenges that comes with students is, okay, what happens with the b's? How do I divide when it comes to those letters or those variables? Okay, well, I'm going to do show you how to do this. So first of all, let's take care of the numbers first. We're going to take care of the things that are alike. And that's how division happens when it comes to simplifying in this particular situation. So noticing that, and also let me say this, okay, so here we go. The 18 is attached to the b squared. We mentioned before, and this is in our earlier session, that whenever you see a number attached to a variable, and there's no operation like literally written between them, like a plus or a minus or a division between them, then the operation that's assumed is multiplication. So what we have is 18 multiplied by b squared. And then in our denominator, we have 9 multiplied by b. All right. So what I'm about to do for you works because the operations are, everything is being multiplied. Well, everything in the numerator is being multiplied and everything in the denominator is being multiplied. I don't have any addition or subtraction going on. So when I have a situation like this, here is how we tackle it. So this is what we're going to do. We're going to take a look at the numbers and compare the numbers. And then we're going to take a look at the variables and compare them. So 18 divided by 9, that's simply going to give us the number 2. All right. Now, how do we tackle the b squared and the b? Well, remember that b squared is the same as saying b multiplied by b, all right? So the square or the exponent tells us how many times we're multiplying the base, which is our b in this case, by itself. So we're multiplying b by itself, and then in our denominator, we have 1b there. Now, remember, when you're dealing with fractions, for example, if you had the fraction 3 over 3, what you would do is say, I can just, 3 goes into itself once and 3 goes, so that's 3 over 3. That's going to give me 1. And a lot of people might say they cancel each other out, which is a good way to say it. And so when we're dealing with numbers, it's pretty straightforward for most people. But when we're dealing with letters, sometimes we're not sure if that's the same thing. And it is the same. So what does that mean? Well, I have a common b in my denominator and a b in my numerator. So the two b's, or the one in the numerator can cancel the one in the denominator. All right, so that means that I'm left with one of the b's. Go ahead and replay that if that was not too clear, but there's another example of it, okay? So that will help us to practice it one more time at least. So that would be 2b. There's another rule for it that says that if the bases are the same, we can subtract the exponents, but I'm just not going to get into that right now. I'm just going to upload a separate video for that. So let's take a look at the next one. We have 16x to the power of 5 divided by 8x squared. Now, we're going to tackle the numbers first. So 16 and 8, let's divide those two. And then we're going to tackle the x to the power of 5 and the x squared. All right, so let's do first things first. So 16, a positive 16, divided by a negative 8 is negative 2. Okay, so we have a negative and a positive being divided, and our result is negative, and then 16 divided by 8 is 2. So now that we've tackled that, let's take a look at the variable x to the power of 5 and x to the power of 2. So I'm going to write it out all the way. So x to the power of 5 is the same as saying x multiplied 5 times. So x times x times x times x times x. Now, the only reason I'm writing it out all the way is so that you can see it. But you don't have to write it all the way. But yeah, so x squared is the same as x times x, so x 2 times. So now I'm going to cancel out whatever's common between the numerator and the denominator. So I have one x that can cancel with in the numerator that can cancel with one of the x's in the denominator. And I have another x in the numerator that can cancel with another x in the denominator. Now at this point, I don't have any more x's in my denominator that can cancel with any in the numerator. So I'm just left with 3 x's, which is the same as saying x cubed. All right. So you can try that on your own again. And yeah. So let's take a look at this one last example here, because in this particular situation, I have 2 variables. I have an A and a B here. All right. So what do I do when there's more than one letter? Well, you do the same thing, but you just need to take your time. All right. So let's take a look at the numbers, and then we'll take a look at the letters one by one. So 21 divided by 3. All right. So 21 divided by 3 will give you 7. And then what we're going to do is we're going to take a look at the A's. So we have A squared, and it's being divided by A. So A squared is the same as A times A, and that's divided by A. And we can cancel out whatever's common from the numerator and the denominator. So there's one A in the numerator and one A in the denominator that's common. And so I'm left with just an A. All right. Now I can put that in there. So that's 7A. And then the last one is the B's. Let's take care of the B's. Well, if I take care of the B, I have a B in the numerator and a B in the denominator. And I'm going to write it out just so you can see it. So that's B divided by B. And what happens here? Well, it's the same thing. So I'm going to just cancel out one in the numerator and one in the denominator. So I don't have any more B's left. I just have like a 1. But since I don't have any more left, then 7A would be my final answer for when I'm simplifying using division. I'm going to go ahead and tell you this. If you're not sure, well, there's another rule for this that's very simplified, and I'm not going to go too much in depth, but go ahead and check out on the YouTube channel the video that's going to be on laws of exponents or rules of exponents, and that will help to make this more clear, and also it will give you a shortcut to doing questions like this. Okay, so now evaluating expressions. We talked about adding and subtracting, multiplying and dividing when it comes to simplifying expressions. But now what happens if you're in an exam and they tell you to evaluate an expression? What does that even mean? What does that even mean? So one thing that's very important to know is that when you're in a math class, and I said this before, but when you're in a math class, we don't like to have to tell you everything. We like to give you one word, and the assumption is that you'll know what that one word means and you'll do everything that that one word means to do. And so let's talk about what it means to evaluate. And you can literally find this definition on Google if you're not sure, but it says the process of finding the numerical value of an expression or an equation. So literally, this is how when you're talking, or when they tell you to evaluate something, they're looking for one answer. So one of the challenges was when you're dealing with simplifying, sometimes it's hard to know if my answer should be multiple things or if it should just be a number. You're not sure. When it comes to evaluating, yes, we're looking for an actual number. When it comes to simplifying, you're applying operations based on whatever variables and coefficients you have, but you're only able to combine like terms if you're adding and subtracting and so forth. So with simplifying, it's a little bit different. Your answer can vary, but evaluating, your answer is pretty much a number. Now, this number does not have to be a whole number. It can be a fraction. It can be a decimal, any of those things. But we're looking for an actual number when we say to evaluate something. And in other words, it means to calculate the value of. Okay, so let's take a look. Now, there are 2 types of problems that I came across when I was looking through the past papers when it comes to evaluating. Some of the questions look like the first one, type 1, where you have 45 divided by, and you have 8 minus 3 in parentheses plus 6. So in this case, you would be dealing, notice that you have multiple operations here. So to answer this question, you would be dealing with order of operations. in math, there is a preferred order. Now, why is there a preferred order? One of the reasons there's a preferred order is because if you just decide to do any or start with any of the operations first because you just like addition first or because you just like division first, you're gonna get different answers every time. And so across the board in math, it's just to come up with a preferred order in which we tackle our operations so that at the end of the day, whether you're here or you're in China or you're in any part of the world, you'll still get the same answer. All right. So order of operations is what you will do to a question that looks like this, where it's just a bunch of operations and there's like just just different terms in there. Now, and there is a video on order of operations that's separate from our time together. And then the second type is where they tell you, okay, I'm going to give you, or I'm telling you that F is equal to 6 and G is equal to 2 and K is equal to 12. And then they say, calculate the value of these things, A, B, and they give you some stuff there. So we're going to focus on the type number 2, all right, during our time. We're going to focus on this and not the first one. And once again, you want to check out that video on order of operations or PEMDAS. And that will help you to answer questions like type 1. So let's get into that. Okay, so we're going to start with that actual question. They would say, okay, evaluate this or something like that. So it says, given that F is equal to 6, G is equal to 2, and K is equal to 12, calculate the value of, and we have 2 parts to this question. Now, let me explain what they're saying to you. Now, remember, at all of these letters, F, G, and K, these are variables. One of the definitions that I mentioned about a variable is that variables are numbers, but are letters, but they represent numbers. They can change. In other words, we can decide that F can be in any number. And what we're expecting you to do is, okay, if I plug in or if I substitute F for the number you're given, what value do I get back? So let's look at part A for a second. All right, so part A says KG. Now, some students, what they'll do is they'll say, okay, K is 12 and G is 2. So, well, the answer must be 122. But you would not be correct, and I'm going to tell you why. What you have to notice is that the operation that's happening between 2 variables that are sitting next to each other, if they're just sitting there, the assumed operation is multiplication. So you're multiplying. So really what's happening is you have K multiplied by G. All right. So the answer is not 122, but instead I can rewrite this just so you can see it. It's going to be the same as K multiplied by G. All right. Now you can take that in for a second and we're going to keep going. So what is K? Well, in our question, it tells us that K is 12 and G is 2. All right. So K is 12 and G is 2. So now I can actually do the math. And this is where I mentioned before, when it comes to evaluating, they want you to find the value of this answer. All right. So, 12 times 2 is 24. All right. So there you go. Now let's take a look at the part B. All right. So part B says F plus G, I'm going to just write it out. F plus G is divided by K. Let's tackle it. So F in our question is 6 and it's being added to G, which is 2. And that answer is being divided by K, which is 12. All right. So now let's go ahead and do the math. Now notice if you just look at the whole thing, I have something in my numerator and something in the denominator. So I'm just going to take a moment. I'm going to simplify what's in my numerator first and then take a look at the whole thing as a fraction. So we know that 6 plus 2 is 8. So 8, and that's going to be over 12. Now, for the most part, whenever you have a fraction, you want to check to see, can I simplify or can I reduce this fraction? Okay. Are there any common factors in between the numerator and the denominator? And when I say factor, I want you to think about a number that can go into both the number 8 and the number 12 without any remainders. So a common number or a common factor between 8 and 12 is the number 4. So I'm going to divide the numerator by 4 and the denominator by the same number. Some students tend to divide the numerator and denominator by a different number, but you don't want to do that when you're reducing a fraction. Okay, you want to use the same number. So 8 divided by 4 is going to be 2, and then 12 divided by 4 is 3. So my answer in this case is 2/3. So notice that when I'm evaluating an expression, I have a number, I have an actual answer that's given back. Now, I have not seen where you get something else, like some random stuff that are not numbers back as yet. And so if I do see that in the future, I'll come back and say, I'm sorry guys, I was wrong. But for the most part, this is all I've seen in terms of evaluating. They're looking for you to give, and this is just based on the definition of evaluating. They're looking for you to give back an actual value as your answer. All right, so I hope that clarifies something for somebody. And let's take a look at another example just like it. So when A is equal to 6, once again, B is equal to -2, and C is equal to 0, calculate the value of, and they give you some kind of expression that they want you to calculate. Now remember, we're looking at what operations are happening. What you're not going to do, I'm going to put a big NOT right here. Do not do. Don't take the numbers, let's say AC, and say, okay, that's a 6 and C is 0, and that becomes 60. This is wrong. This is incorrect. All right. We're going to look at the operation. We have A sitting next to a C. The operation between two variables, or a coefficient and a variable, is always multiplication unless it's written as something else. So for example, if they had A divided by C, then obviously by C, sorry, I put a 6, that's obviously division. If they have A minus C, that's obviously subtraction. If they have A plus C, that's obviously addition. So, but if they just have A and C sitting there, the assumed operation is the only one that's left, which is multiplication. All right. So I hope that clarifies something for you all. So I'm going to rewrite. Let me take this off the screen for someone says, Ms. Nelson said XYZ, and I did not. Okay. So I'm going to write it with the operation in between it. So it's A times C. All right. And that's subtracting 4 multiplied or times B. All right. So what is A? A is 6. So that's 6 multiplied by, what is our C? Well, C is 0. And we're subtracting that answer from 4, or we're subtracting from that answer 4 times B, which is a -2. All right. So let's take a look at that. So 6 times 0 right here, that's going to give us a 0. And then we're subtracting from that 4 times a -2. So we have a negative times a, well, notice it's a negative in front of the 4. So if you want, you can say -4 times -2. You'll get the same answer. So let me just do it that way. -4 times a -2, that's going to give us a +8. All right, so 0 plus 8. And so our answer is just simply going to be an 8. Okay. All right, guys, let's keep on going. All right, so this is how you would tackle a problem. If they say calculate, they'll tell you, like I said, they'll tell you what A, B, and C are. They'll tell you what the variables are, and all you're going to do is substitute them. But you have to pay attention to the operations. Keep in mind, if you have 2 letters, which are considered variables, or if you have something like a 2 sitting next to a variable, the operation happening there is multiplication. And so you just want to keep that in mind. All right. So let's keep on going. Let's keep on going. Our time is like super going too fast. So in terms of our conversation on expressions, when it comes to our vocabulary, you know, the different parts of expressions, simplifying them and evaluating them, we're done so far, but we're going to tackle writing expressions from word problems. Okay. Now, we're probably not going to get a chance to finish all of it, but whatever we don't finish, we'll pick up next week. Okay. So let's talk about it. Vocabulary. We're going to start with vocabulary. Now, how math works. Usually you're used to seeing, okay, multiply 1,400 by 7. Like they give you the equation and you just solve it. But what happens when it's words involved? Well, when there are words involved, what you want to do is look for these little key indicators or these little hints that the operations exist. So, for example, if I say the word sum, S-U-M, what does that indicate, right? So how do I know when I'm adding? How do I know when I'm subtracting? How do I know when the word problem is telling me to multiply or divide? Well, let's take a look at some little keywords that will help us to figure out where we're going in the question, okay? Now, let me be straight up and tell you this. Even though you see these words, practice is going to be key when it comes to word problems. Practice is key, okay? Maybe you'll wake up one day and everything will be clear as crystal and you'll be able to do this. I don't know. I've never seen it happen. You can be the exception. But generally speaking, practice, practice, practice. The more you engage with word problems, the more you'll be able to literally see these like indicating or these things popping out at you and you'll be like, oh, I know how to do that. That's addition, right? So let's take a look at them. So when do I use addition? So here are some key ways to know. If you see the language or the words in all, how much did they drink in all? That's telling you that, oh, they want a combination. They want all of them. I'm going to count everything. All right. If you see the word combined, like for example, if they say Sally earned a certain amount of money and John earned a certain amount of money, how much is their combined earnings? Well, combined is telling you that you're adding. You can take a screenshot of this, by the way, or you can write it down. But whatever you do, these are some of the indicators that, oh, addition is happening between something. You might not know what needs to be added right away, but what you can do is if in the word problem, if you see these words, just put an addition on top, okay? And then, think about what's actually happening. All together is very popular. The word sum, S-U-M. I know when I said sum earlier, some of you were like, S-O-M? No, S-U-M. That's one of the challenges with English. Like we have words that sound exactly the same, but they spell different. And then some that are spelled the same, but they mean different things. So S-U-M is an indicator that we're talking about addition, increase, or total. All right. So let's look at an example that we might see these words in word problems, and that can help us. All right. Now this question is adapted from the BGCSE paper. And so you might have seen this before. It's not the same. It's just adapted. It's an adaptation. So it's not the same question, but it looks exactly like one of them you may have seen. All right. So it says Mrs. James filled 5 glasses with milk. Each glass held or holds 300 milliliters. How many liters of milk were used all together? Okay, how many are used all together? Now, for the sake of this question, so it's not too complicated, I'm gonna just let it remain milliliters, and because I want to make sure you just get the foundation of how these work. So, yeah. So here it is. So 5 glasses are filled with milk. Each of them have 300 milliliters. So we have 300 here. And for every one, we're going to have 300, okay? 300, 300, and 300. Now, there's also another operation that we can see here, but let's just focus on addition for a moment. So how many milliliters of milk were used all together? Well, if I'm saying all together, then I'm adding all of them up. So 300 plus 300 and so forth. So we have 1, 2, 3, 4, 5. So we have 1,500 milliliters of milk. Now, some teachers are very they really want you to use your units, and that's important too. So 1,500 milliliters. So now, is this a situation where you can use multiplication as well? Well, yeah, you can. How do I know? Well, we're going to talk more about multiplication, but whenever you see repeated addition, like you have to add the same thing over and over and over again, you can also multiply. But the word altogether is an indicator that addition is happening. All right, so let's look at another example. Jesse had $25 and he spent $6.50 on lunch and $10 on top up. For those of you who are not from the Bahamas and have no clue what I just said in terms of top up, pretty much back in the day, you would buy a phone card to call somebody. That's what we mean by top up. Okay. But yeah, so what is the total amount of money spent by Jesse? Total. So the word total is an indicator that you're adding the total that was spent. So we know that he spent $6.50 and he spent $10, and total indicates addition. So he spent a total of $16.50. All right. This question is adapted from the BJC paper. And so this is these are just indicators, things that you can look for in these questions. Now let's shift gears. When do I know when I'm going to be using subtraction, right? How do I know that I'm going to be getting a smaller answer? Well, here is how we know. Look for the words like difference. Now, all of these words, there's more. There's a lot more words out there, but these are just the common ones you might see or come in contact with on these exams. The word difference, how many or how much more, minus, less, fewer, decreased, remaining or remain. These are words you want to look for, right? You can take a screenshot of that as well. So that's going to help you to figure out, okay, what am I dealing with? And whenever you see these words, all I want you to do is go ahead and just put the operation, like the actual symbol on top of the word. Like just put the plus there and then take a look at what's going on. Read the question so you have an understanding of it and see if that operation fits somewhere in there. So let's look at an example from our exam and see how we might be asked a question. So it says calculate the difference in between the prices of the fans. All right, that's what it should say, between the prices of the fans. So in the first store, you have a fan for $50. In the second store, you have a fan for $45. Oh, okay. And this is adapted from the BJC paper as well. But if I want to find the difference, what I'm going to do is simply subtract the numbers. So 50 minus 45. That is going to be equal to 5. So the difference between the prices of the fans is $5. All right. So that word difference, like I said, you can go ahead and just put the subtraction sign there, just so that you know, oh, okay, that's an operation I'm familiar with. Let's look at another example. Okay. If you have any questions for me, you can always type it on in the chat. Okay. All right. Let's keep going. Roberto is 150 centimeters tall, and Miranda is 125 centimeters tall. How much taller is Roberto than Miranda? I'm having like a hard time pronouncing his name, but how much taller is he? Right? So how much taller, how much more? Okay. What's the difference in their heights? That's another way this question can be asked. All right. So you're going to go ahead and subtract. So 150 minus 125. That's going to give you 25 centimeters. So he is 25 centimeters taller than Miranda. Okay, I'm hoping this is helping somebody, or at least helping you to kind of get an idea of how I know when I'm multiplying, or, well, in this case, subtracting or adding in a word problem. All right, next one. When do I know I am multiplying? Here are some key words. You can take a screenshot of this, or you can write them down as well. If you see the word times, in all, each, product, twice, or the word double. The word of in math is very popular when you're dealing with percentage. If I say 25% of a number, that's multiplication, people. That's multiplication. And then factor. These are words that tell you are going to multiply. All right. So let's look at a word problem and see. So here we go. Tanya is M years old. Sandra is 6 times as old as Tanya. They want you to write an expression in terms of M to show Sandra's age. Okay, so here's what we know. We know that Tanya is M, so Tanya is M years old. Even if they say she was 5, it's the same concept. It's just that they're using a variable to represent her age. So at this point, it really doesn't matter how old Tanya is. What we want to know is how old is Sandra. So an expression would be, it says Sandra is 6 times as old. So times is a representation or a indicator that we're multiplying something. So Sandra is 6 times the age of Tanya, and Tanya is M years old. So we can say 6M or 6 times M or 6M. That would be the expression that represents the age of Sandra. All right. So let's keep going. Now, what that also tells us is this. If Tanya was 5, then we know Sandra would be 6 times 5. If Tanya was 10, then we know Sandra's age would be 6 times 10, right? So that's what's happening here. All right, let's take a look at another example for you. Jamie bought 5 pizzas. Each pizza has 8 slices. How many slices of pizza does she have in all? Oh, all together. Okay. So she has 5 pizzas. So 5 pizza. And for every pizza, she has 8 slices. So that's going to be 5 times 8. What's another way I can look at this? Well, for the first pizza, she has 8 slices. For the second pizza, she has 8 slices. For the third pizza, she has 8 slices. So we're repeatedly adding 8 slices every time. And repetitive, or when we have a repetition of addition or adding the same number over and over, that's an indicator of multiplication also. So we have 8 times 5, which is going to give us 40 slices. All right. So in all together. Now, last one. What about division? How do I know when I'm dividing? Here are some words you can look for. All right. Now, let me be very clear. Just because you see the words, it does not 100% that this is actually what's happening. What I want you to get in the habit of doing is just being aware of what keywords are in the problems, are in the word problems, and what those keywords can tell you about what your expression should look like. That's what we're doing here. All right, so the words that are here, these are indicators. These are things you can look for that can push you in the right direction when you feel like you're so stuck and you don't know what to do and where to go, okay? So the word half, each, quotient is very, very, very popular. Equal groups, shared equally, distribute. These are words that indicate that you're dividing, okay? You're separating them into groups or so forth. So let's look at an example of this. All right. Tanya is M years old. Same question, just but a different scenario. Sandra is half as old as Tanya. Half. That represents a fraction. I'm halving something, or I'm dividing something by 2. I'm cutting it in half. So literally, if Tanya is M years old, so we have Tanya, she's M years old, and Sandra is half Tanya's age. So Tanya's age is M, and Sandra's age must be M divided by 2. All right. Good. All right. Let's take a look at the next question. Well, oh, there we go. So we have a couple more practice questions, but these practice questions are going to integrate some of the other like multiple operations, whether addition, subtraction, multiplication, or division. So let's just take a look at them one by one. We're going to indicate or show those little keywords that are in the problem, and that's going to help us to navigate it. Okay, so we have about 2 problems that we're going to take a look at before we finish. All right, so this is a long one, but this is coming from the BGCSE paper. And let's go. Ashley bought skateboarding equipment. Now, when you see questions like this, I don't want you to faint. Okay, no, don't faint in the class. Just take your time. You can do it just one word at a time, one sentence at a time. And we're good. All right. So Ashley bought skateboarding equipment. The safety pads cost a total of $40. Okay. The skateboard cost Y more than the safety pads. So I'm going to just go ahead and underline that more than, right? Because that was one of our key words. The helmet cost $10, and this should say less than the skateboard. All right, so that's the information they gave us. Now, what did they want us to do with that information? Write an expression in terms of Y for, now part A says, the cost of the skateboard. All right, so we're interested in knowing the cost of the skateboard. Now, how do I deal with a question like this? Let's look at this. So the first part of the question tells us about the safety pads. We know the cost of the safety pads. But notice that the cost of the skateboard is based on the cost of the safety pads. It says it's cost Y more than the safety pads. So whatever the safety pads cost, the skateboards are going to cost Y, whatever Y is, more than that. So what does that mean? That means that I need to figure out what's the cost of the safety pads, and the cost of the skateboards are going to be Y more than that. So the safety pads, so I'm going to use SP, is $40. All right. But the skateboards, so SB, SB is Y more. More than is an indicator of addition. So it's going to be $40 plus Y. Okay, so it's Y more than. All right, so this is going to be the expression in terms of Y for the cost of the skateboard. All right, I want you to think about that. Let that sink in a little bit. At this point, if you kind of like drifting off a little bit, sit up or take a walk, get some water and come back. All right. Now let's look at the cost of the helmet. All right. I'm going to try to move some of these colors here because it can be a lot. All right. So cost of the helmet now. The helmet, we need an expression for the helmet. So it says the helmet costs $10 less than the skateboard. So what does that mean? That means that we're going to take a look at the cost of the skateboard, and it's the helmet is going to be $10 less than whatever that is. So luckily in part A, we already found the cost or an expression for the cost of the skateboard. So the skateboard, SB, is 40 plus Y. Now the helmet, which is H, is $10 less. Remember that was a typo, so LESS, right? So $10 less. Less is an indicator for what operation? Subtraction. All right. So if you were thinking that, good job. Now, so $10 less. So whatever the skateboard was, so $40 plus Y, and we're going to subtract 10 because that is the helmet is 10 less. Now, notice that we're not quite done yet because we have 40 plus Y minus 10. If you see like terms, if you see that you can combine like terms, go ahead and do that. So what are the like terms in our example here? The like terms here would be the 40 and the minus 10. Why? Because they're both constants. They both do not have any variable. So if I would combine them, that would be 40 minus 10 is 30, and then plus Y would just tag along. Okay, so the expression for the cost of the helmet is 30 plus Y. Okay, so now the next question says the total cost of the helmet. Total cost of the equipment, so the total cost of the equipment. So let's look at all the equipment that was bought. We know that the skateboard was $40, right? Now, because they said total, we know that we're adding, right? So total tells us that we're adding. 40 is the cost of the skateboard. The safety pads. So 40 is the cost of the safety pads. The skateboard, we saw in part A, they asked us what the expression was for the cost of the skateboard. So that's going to be plus 40 plus Y. And then we're going to do the cost of the helmet, which is plus 30 plus Y. All right. So let me be very clear. 40 is the cost of our safety pads. 40 plus Y is the cost of our skateboard. And 30 plus Y is the cost of our helmet. All right, so you're going to go ahead and combine like terms in this one. And when you're done, because they want your answer in simplest form, then you'll get it. So all of our like terms, let's go ahead and combine all of our like terms. So we have the 40 and the 30. So these are all constants. So they're all like terms. So let's go ahead and combine those. So 40 plus 40 is 80, plus 30 is 110. And then our Y's are like terms as well. So we have one Y here and another Y here. So if I have two Y's, that will go here. So 110 plus 2Y. And so this is the expression for the total cost of our equipment in its simplest form. Now notice we kind of combined everything we've been talking about since Sunday to now, combining like terms, and now we're talking about writing expressions from word problems. Now what I'm going to do is I'm going to go ahead and put this up here. This is your muscle work. I'm going to try to stop saying homework, but this is your muscle work for now, between now and next Sunday at 5. All right, so tune in next week, 5 o'clock. And even if you're watching the rebroadcast, that's fine. Or you're watching it at a time that you actually can be there, that's fine, okay? But try the question, and when I come in on Sunday, I'm gonna start here, and then we're gonna keep rolling, because that's when we're gonna get into solving equations. We're gonna talk about solving equations with 1 step, 2 steps, multiple steps, equations where there's variables on both sides. And yeah, that's going to take up our time. Okay. So I'm looking forward to that. Now, what are we going to do before we go together? What about equations? We know that. All right. So we're also going to talk about when do I cross multiply? I remember one time I was working with someone, and every time I asked a question, the answer was, I said, what do you do? They said, cross multiply. And I'm like, look, cross multiplication is not the answer for everything. Okay. It's not. So how do you know when to cross multiply? We're going to talk about that and make that very clear for you, when to do it and when not to do it. And then we're going to get into some more word problems when it comes to equations. Okay. Now, the last thing is our study tip. What is the study tip? Last time we talked about something. Okay, I want you to tune in now and to the first one and look at that first tip. But the second tip is to set study goals. All right. Now, the first tip actually was just that. I'm just going to tell you what it is. Was that you want to break up your study time. That's when you're going to be most effective. If you find yourself like falling asleep, go and just pause, take a breath, and come back. All right. But let's say you decided now, okay, I'm going to break up my study time into 30 minutes a piece or 20 minutes a piece. Well, in order to be effective, you did a good job by breaking it up. Now we need to go ahead and set goals. All right. If you don't set goals for anything, then you don't really know if you've accomplished anything. So you want to set goals. So what do I mean? If you said to yourself, and I kind of talked a little bit about this for Sunday session, if you want to go ahead, if you want to, let's say you broke up your study time into 2 different times, like 2 30-minute sessions, set goals for each one of them. You can say to yourself, okay, I want to be able to solve a linear equation, or I want to be able to solve for X when the variables are on both sides of the equation. That's your goal. All right. So what you're going to do is you're going to find a sample problem from your book, from your notes, or from your textbook. All right. You're going to find some sample problems, and then you want to do 6 to 10 similar problems you can do online. You can just go online and type it in. One of the things that students often can do is, for example, you use your phone all the time. Use your phone to go on Facebook and all TikTok and all that stuff. But for some reason, when it comes to figuring out how to find practice problems, we're like super lost. Okay. So go onto Google or whatever search engine you want to look at and type in whatever they, so let's say you said you wanted to do equations with variables on both sides. Go to Google and type in equations with variables on both sides worksheet. And then you can go to the image section and they'll show you some worksheets with those different types of problems that you can use for your practice session or for your session. All right. So with that being said, that's our time. Thank you all for joining. And let's make sure we go back and take a look at our homework problem. I'm really excited. I'm looking forward to our time on Sunday, and I will see you later. Bye.